afternoon. Welcome, Professor Dutour. Welcome, everyone. It's noon in Jeddah, so it's time for us to start our cultural heritage lecture. I'm Dr. Laurent Sapio. I live and work in Saudi Arabia since 10 years. I'm an archaeologist working at King Abdullah University of Science and Technology. I'm conducting some archaeological research and cultural outreach. In this framework, I've been organizing a cultural heritage event series since a few years. But because of the sanitary situation, it's becoming now a webinar series accessible from everywhere in the world. The cultural heritage event series aims to increase awareness about the unique cultural and archaeological heritage of Saudi Arabia, covering a wide range of topics. But sometimes we also make some digressions and have a special edition. This is the case today. We are temporarily taking some distance with Arabia, but today for a topic that resonates with the current situation. Before introducing further our speaker and the lecture, I'd like to make 3 remarks. First, to ensure the quality of the presentation, a video of his talk has been recorded by Professor Dutour, who is confined in a place with intermittent internet. So we all have to be creative to adapt to this new situation. The presentation will be followed by a totally regular Q&A session. You can ask questions anytime using the Q&A tab. Please do not use the chat for that because it's easier to have the record of the questions on the Q&A tab. And they will be answered at the end by Professor Dutour. Last thing, please could you fill a very short poll. It's just for me to understand the composition of the audience. So thank you for that. I will put it now. And I think it disappears once you voted. So it's a great pleasure for me today to welcome Olivier Dutour, professor at the École pratique des hautes études, Paris Sciences Lettres University, and researcher at the research unit PACEA, CNRS, University of Bordeaux, Ministry of Culture. I had the chance to have Olivier Dutour as a professor a few years ago in the framework of a Paleo-pathology diploma. A few years ago. And so I immediately thought he's the right person to make a presentation about epidemics and their place in the history of human societies. Indeed, Professor Dutour develops his research in biological anthropology, paleopathology, and paleo-epidemiology, mainly focused on the history and archaeology of diseases, and more particularly on the question of human infections in ancient societies. His multidisciplinary approach touches on epidemiological anthropology, health ecology, and the history of medicine and disease. He works on the history of pathogens such as plague, tuberculosis, leprosy, syphilis, typhus, and smallpox. So thank you very much for accepting our invitation, Professor Dutour. The audience is yours. So if it is okay with you, I will launch now your presentation.
Yeah, sure, that's okay. Thank you very much for your invitation.
Thank you very much. It will take me a few seconds to switch. Okay, is it okay? Oh. Sorry. I will. Okay, and so here it is. Here it is. I think we're good. Thank you.
Good afternoon. Thank you for inviting me to give this talk about the place of epidemics in the history.
Il n'y a plus de son.
Good afternoon. Thank you for inviting me to give this talk about the place of epidemics in the history of human societies. First, some words about humans and microbes. Microbes exist everywhere in the world when physical conditions permit them to live. And all the living species, human, animal, plants, are completely dependent on microbes because they help to digest food and they provide nutrients to living species. They degrade organic matter or toxic chemical, and they play as well a key role in geochemical processes. They are the core of biotechnology, antibiotics, antitumor agents, and humans harbor billions of microorganisms in their digestive tracts, at their skin surface, constituting microbiome and contributing to the human health. However, if there are good microbes, pathogens exist as well. But it's not a rule, it's rather an exception. Considering this pathogenicity, it concerns a very few proportion of microbes. There are different microbes, microorganisms responsible for infectious disease. Viruses, prion, bacterium, protozoan, fungus, and parasites. Pathogenicity, as we said, is not a rule for the microbes. We can quote Lewis Thomas, who was a poet, an essayist, but also a dean of Faculty of Medicine in the United States. And as a physician, he wrote that with a sense of humor, that pathogenicity can be a disadvantage for most of microbes. And for instance, a man who catches a meningococcus is less at risk than a meningococcus who catch a man. So pathogenicity sometimes is not the good option for microbes. Anyway, human pathogens exist, and we can say that humankind is among the living beings, the species which have the greatest number of pathogens, probably because of the exceptional demographic growth of human populations during the history and the unique ability to transform the environment, leading to the concept of Anthropocene as being a new geologic era. So that is to say that there are about 1,400 microbial species that are pathogenic for humans. And these species are represented in decreasing order by bacteria, fungi, elements, viruses, and protozoa. What is important to note is that more than the half of these pathogenic species are from animal origin. The relationships between the host and the pathogens is tending usually toward an equilibrium between the resistance of the host and the virulence of the pathogens. So the two species have a common interest to adapt themselves, one to the other. There are some HTP, which is a high threat pathogens, which are the more dangerous human killers. Besides the AIDS, there are Yersinia pestis among them, Mycobacterium tuberculosis, smallpox virus, even if smallpox has been declared to be eradicated by the WHO in 1980, hemorrhagic fever viruses, flu mutated viruses, and coronaviruses with the three species SARS, MERS, and now COVID-19. So there are different levels of infectious disease. Besides the epidemic level, which is an increase in the number of cases of a disease in a given population and in a given area, outbreaks have more or less the same definition, but often it's used for limited geographic space. Cluster is an aggregation of some case in limited space and time. We have the endemic level, which refers to the presence constantly or the usual prevalence of a disease in a population within a geographic area. And finally, pandemic level refers to an epidemic which is concerning several countries or even continents, affecting obviously a large number of people. So the medical progresses of the 20th century, starting by the discovery of antibiotics, you know the story of Fleming and penicillin, Waxman and streptomycin, which was the beginning of the antibiotic era. The introduction of the vaccination, coming together with the antibiotics to fight against the infectious threats. The general surgeon of the United States, William Stewart, declared that it is time to close the books of infectious disease. So we can be optimistic and think that human societies won the battle against the infections. And if we are looking on this curve, actually we can be optimistic and note that indeed there is a great decrease of the frequency of infectious disease responsible for mortality from the beginning of the 20th century to the 80s. Actually, when we are looking at this scheme, we are becoming much more or less optimistic, because we can note that there are more and more epidemic outbreaks since the end of the 20th century and the beginning of the 21st century. And actually, there are more and more new infectious threats, emerging disease, new disease that are responsible for sanitary and economic crisis, sometimes important sanitary crisis. So there are some new mutated flu viruses, such as the swine flu epidemic, pandemic. There are Ebola fever, plague again, and moreover, new type of viruses with these 3 coronaviruses, that is to say SARS, MERS, and COVID-19. So that's very surprising and frightening as well. But that is to say that, contrary to what the US General Surgeon Stewart said, it's time to reopen the books on infectious diseases. And at the beginning of this new millennium, we have to keep this book open, to read it carefully in order to be able to answer to 3 basic questions, explaining why, how, and when did this new epidemic emerge and spread among human modern societies. First, why epidemics are re-emerging? Because of global changes due to human activities and increasing demography. So population growth is one of the major factors. With all the human activities, as we can see here, there are several sets of factors, including human activities, different activities, human population dynamics, and adaptation of microbes and vector, which is most frequently the consequences of human activities, the use of drug and pesticides, and the disruption of ecosystem due to human activities. So these 3 types of factors due to human activities are responsible for this phenomena. How does this occur? As we say, most of the infectious diseases in humans have an animal origins. And there are multiple mechanisms operating in 2 main steps. The first one is species jumps to human from an animal host. Then the second is a transmission to human. Human to human is more efficient, with more efficiency, and efficiency for transmission and efficiency for spreading. Let's take an example, which is a recent one. In this case, there are 2 wild species, the Chinese rufous horseshoe bat and the Javan pangolin. And these 2 wild species, when they met in different circumstances due to human responsibility, people, they transmitted their own viruses that they are sharing with moderate signs or no symptoms. So they are not contaminated, but they are transmitted their viruses to people, to humans. And these wild animals can as well contaminate domestic animals, or humans can contaminate pets, cats, dogs. And then we can have a new cycle of contamination of this coronavirus. And as we can read with this example, there are highly virulent coronaviruses with epidemic or pandemic potential circulating among wild animal species, but there are interactions between these wild hosts due to a lot of reasons, and this uncommon contact allowed the transmission of this wild animal virus. And it is not finished because, as we saw, the frequency of this new disease is increasing, and it's difficult to predict when and where we will have a new outbreak if we continue to do the same things, the same errors. That's Gary Wong from the Pasteur Institute of Shanghai wrote recently. So, if it's not possible to know the future, let's go and see the past. The past is interesting to document the present for the future. And as Nietzsche said, it is the interest of human population to keep a good memory. And the longest memory allow us to understand important issues such as origin and time of emergence of human pathogens, the natural history of human infections, and how to construct models for future situations with past examples. Okay, what we know today about the antiquity of human pathogens? Few things. We know that there are very ancient human pathogens, maybe tuberculosis. So 16 genera of microbes. On the other side, there are more recent human pathogens, dating from the emergence of modern societies. 6 genera. And there are 2 types of pathogens from zoonotic origins, those who are not adapted to human transmission, and those adapted to interhuman transmission. These are the most problematic. Almost all these pathogens are of animal origins. So the third question is, when human epidemics emerge? Answer is when demography increased, when human-animal interface changed due to human activity, when contacts and exchanges between people and continents developed, and when human societies began to change their environment. Demographic changes, which is the most obvious reason for the development of epidemics. There is a major transition a little bit before 10,000 years ago, at the turning between Pleistocene and Holocene periods. And it was a transition between a period of foraging during Paleolithic times, where people are living in small social groups with family links, and with the demographic size, she is counted with 1 or several dozen. Then, after this period, the majority, if not all the human societies, except some special example, adopted the farm, and they become farmers, pastoralists, sedentary people, living in bigger social groups, hamlets before, then after small villages with a demographic size which can be counted by hundreds or hundreds. So this demographic growth during the Neolithic, so contemporary to the Neolithic demographic transition, the NDT, is contemporaneous with the spread of agriculture across the Old and the New World, called the Neolithic Revolution. So in Europe from the Fertile Crescent and other focuses in the world, including the New World. So this increasing of demography can be attested by the increase in archaeological artifacts, the number of size of archaeological sites of settlements, and the demography of Neolithic cemeteries. And in parallel, this transition was accompanied by the first epidemiological transition. So that's the beginning of the epidemics because of the demography. So it is obvious that this period was a period of change in terms of demography, with increased fertility, which is the consequence of the sedentarity, short reduction of birth interval and shortening of the breastfeeding period, which is correlated, increasing birth rate and mortality rate, but more birth than death. So it means that it's the growth rate of the population is positive. And it contributes to the increase of the demography. And this signal can be detected from the Neolithic, pre-Neolithic, Neolithic, and post-Neolithic cemetery. And Jean-Pierre Bocquet, for instance, has established a method to detect this increasing of mortality linked to the increasing of demography by looking at the the youngest part of the skeleton in contemporaneous cemetery. And this increase of mortality rate is probably due to the emergence of epidemics, more severe when concerning the not immune part of the population, the kids, the children. Smallpox, measles, tuberculosis. And as a result, we started with villages, and rapidly there are proto-cities with a lot of people. And it's incredible to think that at the turning of the Holocene, there are big, not villages, but it's almost cities. And at this period, from 10,000 years to 5,000 years BP, we can have this type of settlement up to 30,000 people due to the number of houses that can be counted in the huge sites. So this is the ideal condition for developing epidemics. Population density, promiscuity, poor hygiene, close contact with animals, and commensal companions, cattle, different type of interface, human-animal. And this development of the human interface is at the origin of the different epidemics, coming from wild fauna pathogens, companion animals, dogs and cats pathogens, measles, toxoplasmosis, among others, cattle and poultry pathogen, tuberculosis, brucellosis, flu, coming from birds, rodent pathogens as a commensal, responsible for plague, leptospirosis, and perhaps leprosy. It is a disputed topic. So how to track human infections in the past? By using several sources, old bones, books, and molecules. And regarding these studies of ancient molecules, I refer to the new approach called Paleo-microbiology, introduced at the beginning of the 21st century by Didier Raoult and Michel Broncourt as an emerging field devoted to the detection, identification, and characterization of microorganisms in ancient remains. Infection caused by bacteria, viruses, and parasites that can be all diagnosed using these paleo-microbiological techniques. And this molecular approach of ancient pathogens can reconstruct the epidemiology of past epidemics, feed current models of emerging infections, and contributed possibly to the prevention of future conditions. So the sources for paleomicrobiology are coming from human, animal remains, and as well environmental sources. And this approach constitutes new opportunities for exploring the past epidemics with the microbial genomics of ancient pathogens, which started since 2010 due to the next generation sequencing devices. And this can document the level of the infection, the virulence and the transmission phenomena, host and reservoir, the origin and geographical spread of epidemics, and the genetic diversity and evolution of pathogens. So I don't know if you can read it, but this is some example of some pathogen which has been screened and their genome has been more or less fully sequenced. So there are Brucella, Mycobacterium leprae, tuberculosis, Yersinia pestis, we will talk about, and virus of flu, influenza, and hepatitis type B. So, I don't know if this slide is clearly visible. Anyway, this is some example of the new possibility for exploring the place of epidemics in the history of human societies. And we can now answer some unanswered questions, such as the plague epidemics in the past, the evolution of tuberculosis, of leprosy, of syphilis, when did it emerge, the typhus, smallpox, cholera, Spanish flu, and sweat epidemic. We know nothing about the microbe at the origin of sweat epidemics. It's only history for the moment. So let's take an example about the archaeology of plague epidemics and show how paleomicrobiology can work. So the general epidemiology is very similar to the one of coronavirus. There are wild animals reservoir. In this case, there are vectors, which is small insects, fleas, transmitting the bacterium, the Yersinia pestis. Wild animal can contaminate commensal or domestic animals, such as in coronavirus. And then they can contaminate it as well. The wild and the domestic animals can contaminate it through the flea bite, the human. And then human can contaminate it other human. So it's a human-to-human transmission, which is a strong efficiency in the epidemic spread. So the first archaeological researchers started in 94 on a plague mass grave historically dated from 1722. And at this very beginning of the work, we already played ancient DNA studies. That was just the beginning of this type of research at this very moment. And indeed, in 1988, on this material, the detection of sequences of Yersinia pestis DNA was done using human dental pulp, which was an innovative way at this moment. And this method became the rule now and very generalized approach for studying ancient pathogens. And it was the beginning of the story. And I was one of the participants in this story because I excavated the mass grave. And I thought that it was interesting to do DNA, and I came to Raoult and Droncourt lab to talk with them. And well, finally take the decision to work with a dental surgeon, which was a student at this moment. And he was looking for a topic, a research topic for his master, and it was a nice topic indeed. And that was the beginning of ancient pathogen studies and paleomicrobiology. So there are, after this study, a lot of paleomicrobiological studies on plagues, I would say. And then these studies solved some mysterious question. What was the plague of Athens? It was not Yersinia pestis plague, but the Justinianic plague, the Black Death, medieval plague, and the outbreaks between medieval period and modern period, and the third pandemic, for sure, was genetically really plagues due to Yersinia pestis. And for instance, the history of the common history between plague bacteria and human societies has been reconstructed thanks to these techniques. So it was possible to identify the first emergence of Yersinia pestis in the Bronze Age Eurasian societies. So it was not in China, it was in Europe as well. So Europe and Western Asia. And there is, during the Bronze Age, an ancestral Yersinia pestis who was already infecting humans. And probably there are rodents, commensal rodents, because people used to, well, store their the product of agriculture in big jars, and then there are rodents coming from to eat these grains. So this is another story. That is the reason why the human population decided to domesticated cats to fight against the rodents responsible for the destruction of their grain storage. So rodent, animal, and a bacteria, and contamination of human population during the Bronze Age. The first pandemic, is due to an extinct strain coming from Asia. And you know where is the COVID is coming from. And this first pandemic is due to a strain probably linked with the trade relationships between Mediterranean basins during the Antiquity, Europe and Asia. And COVID is due to human exchanges between Asia and the other part of the world. Second pandemic, also coming from Asia, different strain. So the same difference than MERS or SARS with COVID. So another pandemic, same bacillus, different strain, same origin, again Asia. Same virulences than modern plague, but a lot of population loss. 50% of Europeans, 25 million of victims. So the half of European populations. Then, a surprise. The 18th century epidemic in Marseille is due to the bacillus of the medieval plague or 14th century. It's the same. Because you see on this graph that in green we have the two bacillus DNA of the same group belonging to the Black Death of London in the 14th century. And here in red, you have the sample from Marseille, 18th century. It's the same bacillus, more or less. So it means that, well, the bacillus maybe stay in Europe or around the Mediterranean basin, and probably this time is not coming from Asia. So it's a long persistence of this medieval plague in Europe. So to conclude with, we can say that human societies have transformed their environment, and they have modified the interface with animal communities. This transformation have had consequences on the equilibrium of relationships between species, particularly between host and pathogen, that are responsible for emergent phenomena of infectious diseases. And faced with the brutality of some of these phenomena, human societies have found adaptive responses, both microbiological, biological, and cultural. Thanks to paleomicrobiology, it is now possible to follow up some past pandemics. And then we can see some similarities between very ancient epidemics, starting in the Bronze Age, and which is still continuing in different form with different strain nowadays. But there are some similarity with very new diseases, pandemic diseases, such as modern COVID. So there are animal origin, geographic focus, which is in common Asia, and contamination of people due to animals and inter-human transmission with different way of contamination, including social comportments, traveling, trade, exchanges, and so on. So these two pandemics are not so different. So it showed the utility, the usefulness to know the past, to understand the present. Thank you very much for your attention.
Thank you very much, Professor Dutour, for presenting us this very interesting talk. I have to remove, I don't know if you still see, okay, I have to have the Q&A tab. So we have a few questions already. One from Levante Seri, who asked if there are some viruses that are not pathogens.
Sure, a lot. There are a huge number of non-pathogenic viruses, and there are as well viruses that are pathogens, but not for humans, but for instance for plants. So it's depending on the species, but the biggest majority of viruses are non-pathogenic.
Yeah, thank you. And we have an anonymous attendee saying, thank you for this interesting talk. I understand that some of these viruses transmit from wild animals to humans, but how does these viruses start in animals to begin with? Are they just naturally occurring mutations that happen to be harmful? Thank you.
Well, what I said is that at the beginning of the talk is that it's absolutely normal to live with microbes. So it means that each species have its own microbes, which is not pathogenic or very fewly pathogenic, but it's just a matter of species. So when we are meeting other species, it's possible to be contaminated by microbes that are not pathogenic for the species, but that can be pathogenic for other species such as humans. So it's a matter of species. And we are all living with microbes. So we can contaminate other animals as well with our own pathogens that we have very well adapted with.
Do we have examples of animals that have been contaminated by
humans?
Yes.
Yes, for instance, tuberculosis. So you can have a tuberculosis which is not so symptomatic for you, but that can be lethal for animal species. So actually, the new scenario is that tuberculosis is not, has not been transmitted by cattle to humans, but it's the contrary, because the tuberculosis was human disease, human infection for many years before the domestication. That's a new concept.
That's interesting. So we have another question from Teofilo Abrahano. I'm not sure I pronounced it properly. Have you come across examples of potential epidemics that may have been solved quickly and prevented from spreading?
Oh yes, there are lot of example of control epidemics, fortunately. For instance, plague, which is, well, current, it's more or less endemic in Madagascar. And there are few cases, but all the people are living, these people are living with plague since centuries. They know and they can control the these occasional cases very efficiently. Well, I think that the SARS was in comparison with the COVID-19, but I don't know the reason. Maybe it's a matter of pathogenicity, virulence.
Thank you. The next question is from Professor Herbert Hurt. Is asking, how were the epidemics cured in the past? How did the plague disappear again in the past centuries without having antibiotics?
Sorry, I didn't get the question. Could you repeat?
The question is, how were the epidemics cured in the past?
Okay. Well, in the past, there are no efficient treatments. The only efficient treatment was the prevention. So the best option is to protect the people against any contact. So that the principle of quarantine, which was very efficient. And for instance, in Marseille, there are a lot of plague epidemics that has been avoided by this system of control. So sometimes some epidemics can reach the city, but most of the time it was stopped at the entry of the port.
So quarantine for boats was a common practice. It was all the time, or just when epidemics were coming back?
No, it is an old idea to finally, the discovery of microbes is very recent. But I mean, the common knowledge of the transmission is much more ancient. Hippocrates, for instance, was talking about the interest to avoid contact with people having some disease. So ancient people knows the possibility to catch infectious disease, even if the modern medicine discovered the microbes in second part of the 19th century. So the quarantine was very efficient. Well, when it was correctly applied, that was not the case for the 18th century epidemic in Marseille, due to finally financial interest and corruption of some important people.
That's recent to remember. So there's another question about, so from Jay Schuster, Professor at Karst, he asked, why do some viruses remain in human population while others die out? So I think that's what are the hypotheses about the phenomenon of disapparition and reapparition of the pathogens?
Sorry again, I didn't.
Asking, so the question is, why do some viruses remain in the human population while others die out? There is a lethality for the viruses, or?
Well, we have in our genome some very old viruses. So they are within us. So that the first answer. They integrated their sequence in our DNA sequences. And why the interesting issue, why the epidemics are disappearing? We don't know. That's the natural history of biological species. Well, they are not permanent, and we don't know the exact reason why pathogenic virus or pathogenic bacteria is disappearing finally. So it's a matter as well of immunity of population. If all the population is protected by immunity, so the pathogen has no chance to stay and to continue to live in this population. So it might be a question of lethality, yes. If microbes is killing all the population, there are no more epidemics.
There is a question from Rajani asking if there are any instances of plant viruses jumping into humans.
There are no examples for the moment. There are a lot of examples of animal viruses contaminating human population, but for the plants, there are no examples. So we can eat tomatoes with the virus. There are no human risk.
Thank you. So Ben Willie asking, in your research, I think it's clear how you've used modern scientific techniques, genomic studies of pathogen, by example. So how important is understanding the history of early human social behavior in putting the complete story together? How reliable do you think this sort of knowledge is?
Well, obviously it's difficult to reconstruct the human behavior of the past, but it's a challenge of archaeology. We do have some clues, and we can reconstruct some part of history by using this type of clues. So I talk about the demography and promiscuity is very important, very effective reason for the transmission of the epidemics. And the archaeological discovery of these proto-cities in Middle East, in Europe as well, with settlements, with a lot of houses and the possibility to welcome several thousand of people in the same place. I think it's a good clues to explain that the behavior to be together with a lot of people and a lot of neighbors. Well, it's a good opportunity for microbes and for viruses, but it's not good opportunity for human communities. So it's better to avoid epidemics to be in small communities, family-sized. It's what we are doing right now with the COVID-19. So we are living in family, with relatives, in very small communities or less than 10 people.
Yeah, no. So good, we're doing what needs to be done. That's okay. So I think this answers as well Marie-Laure Boulot questions who ask what we learned from the past, right? And that's the recommendation, and same for Gabrielle Abelskamp, who asked about, except quarantine and living in small community, there's not much more, right, that we can do.
Yeah, That's complicated because we adopted since the Neolithic this type of life. So living in bigger and bigger communities with the urban way of life, with a lot of people at the same place. In the subway, for instance, in the rush hours. So it's a very efficient way for viruses to be transmitted. So what we can do? It's very difficult to change our way of life. It's very difficult for people living in the big cities to decide to leave the big cities and to live in small villages or hamlets. Well, for sure, it's healthier, but it could be difficult to change the the transportation and so the facility to go to Paris from Shanghai in several hours. So that's very comfortable, but that's also a way to transmit infectious diseases. So the recommendation is, well, it's very personal decision, I think.
Yeah. So thank you very much. I think we've been through all questions. So thank you again very much, Professor Dutour. That was a really interesting talk and great to be able to discuss it with you after. So really thanks again. I would like as well to thank everyone who attended. I would like to thank as well Virgile and Abdul Karim for their help. The next seminar will be in 1 week on Wednesday, May 20. We will return in Arabia. So with a talk by Professor Michael Petraglia. Professor Petraglia has been leading a large-scale archaeological project in Saudi Arabia since years, especially the Paleo-desert project, exploring climate change and human evolution in the Arabian desert. So this will be the opportunity to hear about the first human migrations across Arabia and their ecosystem. So I hope you will be there next week. Meanwhile, stay safe and continue practicing indoor culture. Thank you very much.